So Arian, you're asking me a great question, and we're going to actually do a problem. And the first thing we're going to do is calculate s squared between for that problem. So the problem is on page 355. And I'll read the problem for you, and we'll start to solve it as if we were going to solve the whole thing. So a social worker at a small psychiatric hospital was asked to determine whether there were any clear differences in the length of stay of patients with different categories of diagnosis. Look at the last four clients in each of the following three major categories. So the categories are affective disorder, meaning like mood disorder. Sorry? Page 355. So first one is mood disorders or affective disorders. And the values of their length of stay in weeks, let's say, was 8, 6, 4, and 6. Then, now the other group is personality disorders. These people have another type of disorder called personality disorders. And their stay is 12, 8, 9, and 11. And the final group is drug-related disorders. And their stay is 8, 10, 12, and 10. OK, so just let's look at the data for a second. If we look at the data, these guys obviously stay much less than these guys. The drug-related stay quite a bit longer than these. And these seem to be more in the middle. OK, so the question we're interested in asking is there significant differences in the length of stay between these three groups? You know, it's like we've done an intervention. We really didn't do any intervention, but these groups were intact. And this is their length of stay. We're asking, is there a difference in the length of stay of these groups? And the first thing is to calculate the mean of each of the groups, right? So sum of x over n. And we'll calculate the mean for each one of these. So 18, the first one is 22, so that's 10, 18, 24. Is that right? 24 over 4 gives us 6. The mean is 6 here. So mean 1 is 6. Mean 2 is 9 plus 11. 40 over 4, which is 5. Excuse me. 40 over 4 is 10. M2 equals 10. Excuse me. We're in a totally different word now. So 8 and 10, so 20, 20, 32, 40, and this has a mean of 10. OK? So you see the means of these two groups are the same. This group is a little bit off. The question is this significantly off? Is there a real difference between these means? And you can see the variance of this group is limited. You know, you've got the biggest number is 8, the smallest number is 4, and there are 2 6s. The variance of this group, how would you characterize the variance of this group versus this group? Which is more spread? You can't really tell. This might be a little bit more spread. We're going to calculate the variance and tell which is more spread, right? So let's calculate the variance. Let's calculate the variance of each of these groups as if we were calculating s squared pooled. How did we calculate s squared pooled? Let's calculate the variance of each of these groups as if we're calculating s squared pooled. So go ahead and you do it. Basically, you simply calculate the sum of squared deviations, x minus m squared, and divide by degrees of freedom, right, for the first one. So the sum squared deviations, this is your x. X minus m is 8 minus 6, which is 2. 6 minus 6, 0. 4 minus 6 is minus 2. 6 minus 6 is 0. And obviously, this gives us a 0. That's great. X minus m squared is 4, 0, 4, 0. That gives us an 8. And so sum of squared deviations is 8 over 3. Very good. So for the first one, s squared 1, it is 8 over 3, which is 2.67. Everybody got that? S squared 1? That's the variance of the first one. What's the variance of the second one? So you've got x minus m. You've done this multiple times, so I'm not going to focus on it too much. 12 minus 10 is 2. 8 minus 10 is minus 2. 9 minus 10 is minus 1. 11 minus 10 is 1. You add these guys together, and you get a 0. That's right. So x minus m squared gives us a 4, a 4, a 1, a 1. And that's 8, 9, 10. So sum of squared deviations here is 10 over 3. So s squared 2 is 10 over 3. And we are looking at 3.33. And for the final one, again, x, and here is x minus m. 8 minus 10 is minus 2. 10 minus 10 is 0. 12 minus 10 is 2. 10 minus 10 is 0. And you get a sum of the deviation scores, which is 0. That's how you check your work. X minus m squared is 4, 0, 4, 0. And the sum is 8. So s squared 3 equals 8 over 3, which is 2.67. So look at these.
That's 1.11, not 3.33.
Sorry? Oh,
wait.
no, 3.33. Yeah.
Sorry about that.
Yeah. So you can see the variance of this guy, of this group, is the same as the variance of this, but this is a bigger variance. Yeah, this is a bigger variance. Okay, so now we know something about the variances. Now we pull the variances. How do we pull these variances? Anybody want to pull them for me?
Do the average.
Do the average, exactly. So basically take S1, S2, S3, S squared 3, and divide by what? 3. Perfect. So you've got 2.67. So S squared. Now we're going to call it pooled, but instead of pooled, what did we determine we call it in case of analysis of variance? Within. So S squared within equals 2.67 plus 3.33 plus 2.67 divided by 3, by n, the number of scores. 2.67 times 2 plus 3.33 divided by 3 gives us 2.89. This is s squared within. So that's actually half of your struggle. This is the first part of your task, is to calculate s squared within. And you've done it many times before, so it's nothing new. Everybody okay with that? So whenever you're solving an ANOVA, you start out by calculating s squared within. Next is to calculate s squared between. And this is what Arian has been really dying to know. So I'm glad that that's the case. And the way to calculate s squared within is a little bit funny. What you do is you take these means. You see this mean? You take this mean, you take this mean, and you take this mean, and you treat the mean as if they were a score. Okay? So let me do it in red so that it'll be clear. Okay. Would you move the camera so that I'm like here? Okay. Okay. So I'm going to take each of these means that I just pointed to, and I'm going to actually treat them as if they were x. So mean 1 was 6, mean 2 was 10, and mean 3 was 10. So I took the means and treated them as if they are our new x. But instead of x, we're going to call them m, because they're the means, the 3 means. But they're really now going to be treated as if they were x. And all you're going to do now is nothing different from the past. You're going to actually calculate the variance that is associated with these three means. Okay? So you're going to actually end up calculating the mean of means. These are means, and you're going to calculate their mean. Everybody with me? The mean of means has a weird name in statistics. It's called the grand mean, like grand Huba. Grand mean. So the GM, grand mean, equals sum of the means, or sum of x over n, which means it's 6 plus 10 plus 10. That's 26. That's 26 over 3, which is equal to 8.66. Great. Or let's make it 8.7, make life easier for ourselves. So 8.7 is the sum of. So now we're going to actually calculate the variance from these scores. We're going to do exactly the same stuff, but we're going to do it with this new conceptualization of taking these guys. So to calculate the variance, we take each one of these, and obviously we subtract from it. We find, so m minus, we're going to actually just call it x, just to make life a little bit less hectic. So x minus m, right? So 6 minus 8.7, 10 minus 8.7, and 10 minus 8.7. 6 minus 8.7 is equal to minus 2.7, right? And 10 minus 8.7, 10 minus 8.7 is 1.3, and this is 1.3. So this is your if you add them together, you're going to get a 0.1, but that's a rounding error. It should be 0 really, but we'll live with it. Okay, so x minus m squared is equal to 2.7 times 2.7 gives us 7.3, and then 1.3 times 1.3 is 1.69 or 1.7, and this is 1.7. So the sum of squared deviations is equal to 1.7 plus 1.7 plus 7.3, which is 10.7. Everybody with me? Nothing different, really. Now, we divide usually by degrees of freedom. What's the degrees of freedom in this case? 2, exactly. You've got 3 scores, and you divide by 2. So degrees of freedom is 2. So it's 5.35. OK. So the variance here is 5.35. How are we doing on time?
13:30.
OK, you can stop.